Hello and welcome to another Math 104 lecture. So last time when we were discussing in the lecture, we were talking about polynomials, and we were talking about how to handle them as far as multiplication, as far as multiplication, addition, and subtraction. Well, today what we're going to look at is factoring polynomials. So factoring polynomials is essentially the opposite of multiplying them. So multiplying them, put them together, you ended up with a bunch of separate little terms, right, that were either added or subtracted against each other. And then factoring is the going the other way. It's the backwards process, right? So as a game plan for you guys, just so you guys understand, this video might be a little longer than I wanted. And the reason is because we are not meeting on Labor Day. We have Labor Day off. So what I decided to do is I decided to, instead of giving you a lecture going into Labor Day when we're not going to meet anyway, and then another lecture going into the Wednesday after that, I would just give you one lecture going into the Wednesday after that, because the topic that I wanted to discuss after factoring is kind of a subset of factoring anyway, and it's called rational expressions. And we'll talk about that in a little bit, but essentially all a rational expression is just the division of two polynomials. And to divide polynomials, you need to know how to factor anyway, so it really just comes down to factoring. So I'm going to include it in this lecture at the end once we're done with factoring. And the way that we're going to do this is that I'm going to assign two homeworks for this one lecture. So there's going to be one homework purely on the factoring, and then there's going to be an additional homework over the weekend for handling the rational expressions, or the division between polynomials. I will label them essentially as homework part 1, which you guys will go ahead and do ahead of Friday. And then there will be homework part 2, which you will do at some point either over the weekend or just as long as it's before Wednesday. Now, just keep in mind that there's also going to be that other lecture ahead of Wednesday, and that other lecture is also going to have its homework assignment. So I'm kind of doubling up here. You're going to have 2 homework assignments over the Labor Day weekend, but it shouldn't be too bad. I will reduce the amount of homework questions for the rational expressions. Okay? So with all that said and done, let's go ahead and get to factoring polynomials. So what is a factor? Okay, let's go ahead and consider the number 6. So 6 is a composite number. There are essentially 2 main kinds of numbers when we're talking about real numbers. One is composite numbers and the other is prime numbers. A prime number is where it only has 2 factors, and we'll talk about, so this is a good one, 17. 17 is a prime number. The reason is it only has 2 factors, 1 and itself. And that goes for any prime number, right? The only pair of factors for a prime number is 1 in itself. For 6, however, or any composite number, is when you have more than 1 pair of factors. And that essentially means that you're going to have, you're going to have the 1 and the 6, right? But you're also going to have the 2 and the 3, right? So what you would say is 2 and 3 are factors of 6. Okay, so with that definition out of the way, we have to look at the process by which to factor polynomials. And there's a couple different ways that we do it. So the first method is factoring by the GCF, so the greatest common factor. And we'll write this here. So what this means is you're going to look for the largest number, and that also includes variables, that are common between the terms. So the best way to really think about it is with an example, and we'll start with one. So we have 3x squared plus 9x, and I say I want you to factor this. Okay, so the way to approach this is you look at both different terms, and I will underline them. So we have the 3x squared here, and we have the 9x here. And you say to yourself, okay, I'm looking for a number or a pair of numbers that go into both of these. And you say off the bat, okay, well, great. We know that 3 goes into 3x squared, and we know that 3 will also go into 9x, right? But we can do a little bit better than that, because we also see that there is an x present in both. So what we can do is we can pull the x out of 3x squared, and we can also pull the x out of 9x, as well as pulling the 3 from both. And when we pull the 3x out, it's essentially like we're dividing, right? So what's 3 divided by 3? Well, that leaves us with 1. And what's x squared divided by x? Well, that just leaves us with one singular x, right? And we're going to write over here Remember, when you have a variable divided by the same variable, or the base divided by the same base, all you're doing is you keep the base the same and you are subtracting the exponents, right? So that's just x to the first or just x, right? So we pulled x out of the 3x squared. We pulled 3 out of the 3x squared, and all we're left with is x. And now we're going to do the same thing. We're going to pull 3x out of 9x. So 9 divided by 3 leaves me with a 3, and x divided by x leaves me with nothing. And this is what we are left with. We factored it. We broke it into its building blocks. So essentially what this means is, if we were to go backwards, and this is a good way to check for yourself, if I, turned around and said, okay, factor this and then multiply this, you should end up with the same answer, right? So if you do multiply this, you're going to distribute the 3x to everything that's inside the parentheses. So, and I'm just going to write this in green because we're going to erase this in just a second, but this is a good check. So you go ahead and do that, and you arrive at 3x squared, and then 3x times 3 is just 9x, and we see that that's exactly what we had above, right? So that was just a way that you could check for yourself that this worked. Okay, so that's the first way that we can do this. So I'm going to go ahead and let you guys give number 1 on the classwork a shot. And number 1 is, if we have, oops, don't want to be in green, my mistake. If we have 8ax cubed plus 4ayx squared. And I say I want you to factor this. So go ahead, give this a shot, see what you guys can come up with, and then unpause the video when you are ready. Okay, so I hope this was straightforward for you guys. So let's go ahead and do this together. So the first thing that you're going to look at is the coefficients of each of the term, right? So you can look at the variables first. It doesn't matter what order. For me, it's helpful to look at the numbers first. So I see that we have an 8 here, and I see that we have a 4 here as well, right? Which means that we can pull a 4 out of both. So we're going to do that. We're going to pull a 4 out of both, okay? But we're not done, right? Because we still have to talk about the variables. We also see that we have 1a present in each of these, which means that we can pull the a out of both. And we see that we have an x cubed in the one on the left, and we have an x squared in the one on the right. So the most x's that I can take out are x squared, right? I can take out an x times x. I can't take out 3 of them because then the term on the right would be a short one. We can only take out by the lowest amount. So we're going to take out the x squared here. So we have 4ax squared. Now we also have a y, but we only have a y in the expression on the right, in the term on the right, sorry. We do not have a y in the term on the left, so we can't do anything with it. We can't take it out, okay? So, okay, we took out the most that we can. We took out a 4ax squared, and now we just have to go through the process of dividing this out, right? And of course, you could do this in your head mentally when you're pulling out the 4ax squared, or anything else for that matter, but it might help you to just do it again. So 8 divided by 4, we're left with 2. A divided by a, well, that just gives you 1, right? We took out 1a, and there was only 1a present. And then we have x cubed divided by x squared, which just leaves us with x. Okay, now we do the same thing with the term on the right. 4 divided by 4 is just 1. A divided by a is also just 1. We didn't do anything with the y, right? So the y stays there. And we took out the maximum amount of x's possible, right? There was x squared, and we took out an x squared from the term on the right. So we are just left with this. And this is our final answer, 4ax squared times 2x plus y. And again, if you're not confident in this, or if you don't believe me, feel free to go ahead and check. And what you're going to do is you're going to distribute the 4ax squared to both terms in the parentheses. Okay, so hopefully that wasn't too bad. Okay, so that is great for when we have things in common, when we have factors in common in each term. But what happens if we don't? What is our process then? Well, if we're looking at something in the form of ax squared plus bx plus c. So this is the form that we're looking at. This is still very much a polynomial, right? We have the x squared, we have an x, and we have essentially x to the 0 here, right? But x to the 0 is just 1. So we're left with a constant, right? And if you guys remember from the last lecture, this is still a polynomial. This type of polynomial actually has a special name. It's called a quadratic, but we'll come back to that in future lessons. Okay, so if we're looking at something in this form, what we often have to go by is this guy right here, the plus c. That's going to be our first hint. So what do I mean by that? Well, again, it helps to look at an example. So let's start with an example. We have x squared plus 7x plus 6. Okay, so again, looking at this, you say, okay, well, there's nothing that I can directly pull out of all three, right? Technically, if I wanted to, I could draw parentheses here because parentheses don't change the expression, right? And I could pull out an x from those two terms, but that's not really going to help me solve it. It's not going to finish factoring this. And also, as a tip, guys, you will know that everything is factored into the lowest form that it can be when everything is multiplied against each other, when there are no more, when there's no more addition or subtraction going on except inside of a parentheses. So in the last example, we ended up with, I already forgot, but we ended up with something inside of the parentheses that, there was an addition in there. That's okay. Because you had, the 4ax squared on the outside being multiplied against everything, right? So when you do come across a quadratic, though, which is, again, this, you'll know that everything is factored when you have just two things multiplied against each other. Okay, so what are we going to do here? So what we have to do is we have to look, again, at the factors of c. And in c, in this case, is 6. And more specifically, it is plus 6. And this sign in front of the 6 is going to matter substantially, okay? So please keep in mind, you're always going to care about the sign in front of the c. So when we look at 6, we're going to look at the factor pairs, and we're going to write this off to the side. And for the record, I know that some of you guys can breeze right through this, and that's absolutely great. Maybe you guys, saw this in previous classes, and that's wonderful. I still want you guys, when factoring, to write out the factor pairs all the way through the midterm. Okay, so everything that I'm about to write off to the side, I want you guys to include just so I can see the process that you used for your work. Okay. So we have 6, and we're looking at the factor pairs here, right? So obviously the first one that comes to mind is 1 and 6. And then the next one that comes to mind, we already talked about this, is 2 and 3. But are we done? And the answer is no, because remember, it's a plus 6 here, but we were only really talking about positive numbers here, right? Well, there's also negative numbers. So if we have a positive 1 times a positive 6, yes, we will end up with a positive 6. But the same is also said for if we have a negative 1 and a negative 6. And also you can follow that same line of logic for positive negative 2 or positive negative 3. Okay? So the idea here is that any of these pairs, positive or negative, could be the answer for what we're looking for. So that's our first step. The second step that we have to do is now we have to look at this guy right here, the positive 7. Okay? So again, we're looking at b. So in the form of ax squared plus bx plus c, first we look at c, and then we look at b. And the reason that we're looking at b is because the factors from c, or 6 in this case, have to add up to give us plus 7 in this case, right? So we look and see, okay, well, positive 2 and positive 3, if we do this, and I'm just going to 2 plus 3 gives me 5, and 5 is not equal to 7. And we can already assume that all the negative ones are out, right? Because if we have a negative and we add another negative to it, then it's just going to be more negative, and we want a positive 7. So negative 1, negative 6, negative 2, negative 3 are out. We just tried 2 and 3, so that's out. And now we just look and see, okay, well, 1 plus 6 does equal 7. And that's what we want, right? That's exactly what we're looking for. So now that we have the positive 1 and the positive 6, we can then just say, okay, well, this is going to be x plus 1 times x plus 6. And that's it. Now it's factored. And the reason that we know x is going to be the first term in each of the parentheses is because we have x squared here. And we know that when we do end up foiling this out or distributing, the first thing that we do if we are going to multiply everything, and I'll write this in green because, again, this is going to be our check, right? The first thing that we're going to do is we're going to say, okay, well, x times x is x squared, right? If we're doing this times this. And this corresponds exactly to what we had up above, x squared. And again, just to continue with the check, well, when we're foiling, it's first outside, so we get plus 6x plus 1x, and I'm only writing the 1 here just to really illustrate the fact that there's 6x plus 1x. And then last but not least, we have plus 6. And when we condense everything, we end up exactly to what we had up above, right? So the green, not to confuse you, the green was just our check that this worked, but our final answer, our actual answer for factoring was right here, the x plus 1, x plus 6. And again, the idea here was simply that we looked first at the factors of 6, and then we looked then to see what factors of 6 would add together to give us our term in the middle. And again, the signs do matter, right? So we were looking at factors of positive 6, and then we were looking to see what factors of those would add together to give us a positive 7. Okay? So hopefully that makes sense for you guys. Okay, so next up, we have reversing the special cases. So if you guys remember from the last lecture, we were talking about certain special cases. And just as a quick refresher, I'm not going to write all of them. Some of the special cases were like a plus b squared, a minus b squared, and then also a plus b, a minus b, right? And hopefully you guys remember, we're going to end up with, and I'm just going to do this really quickly, a plus b, a squared plus 2ab plus b squared. The a minus b is going to give you something similar, a squared minus 2ab plus b squared. And then this one simply gives you the difference of squares, right? Difference of squares. We have 2 squares here, and the difference being the subtraction. Okay, so these are 3 of the 7 special cases or popular cases that we went over in the last lecture, and now we're going to talk about reversing them. So we talked about multiplying them out, and these would be the answers that you got, right? But now we're talking about going the other way. So let's look at an example. If I give you x squared minus 4, and I say I want you to factor this, so I'll even factor x squared minus 4. You might look at this and be like, okay, well, the first method is we have to look for things that are in common. And right now, there's absolutely nothing in common, right? I can't pull anything out of x squared that I can also pull out of 4. I can't pull anything out of 4 that I can also pull out of x squared. So, okay, that's not going to work. Then we have the second case, which is we're going to look at factors of this guy, right? Well, technically negative 4. But we're going to look at factors there and see, well, we're going to be at a standstill because we don't have a middle term, right? And I'll come back to this in just a second, but I really want to illustrate that we can just reverse this, right? So then you think, okay, well, what are my special cases? And one of the special cases is a squared minus b squared. And this should always be the first thing that pops into your head when you fill 3 criteria. And the 3 criteria that you have to fill are, 1, do you have something squared here? Do you have something squared here, and do you have a subtraction? If you fill all 3 of those criteria, then fantastic, you know that this is just going to be a plus b times a minus b, right? So in this case, we know that 4 is really just the same thing as x squared minus 2 squared, right? 2 squared is still the same thing as 4. And now that we have it in this form, x squared minus 2 squared, that's the same thing as a squared minus b squared. So we just have to plug in. We just follow the blueprint, right? So this is really the same thing as x plus 2 times x minus 2. And that's it. We're just using the difference of squares formula to factor this. And again, just going back to what I was saying before, how do you know when you're really totally factored? Well, you have one term multiplied against another term. There's no other signs going on in between them, right? There's no addition, there's no subtraction. We have something multiplied against something else. That's how you know that it's a factor, right? And again, going back to 6 as our example, 6 is really 2 times 3, right? So if we're talking about factors of 6, 2 times 3, there's no other addition, there's no subtraction, there's nothing else going on. It's just one number times another number. And again, we have one term here multiplied against another term here, and so we know that we're factored. Okay, So you might be thinking, okay, well, what if I don't remember difference of squares? And I'd say, well, I really hope you do, because that's one of the things that I'm trying to drill into you guys early on. But if you really don't remember difference of squares, here's an alternative way to factor this. So again, we have x squared minus 4. Okay. Another way that you can think about this, well, x squared minus 4 is really just the same thing as x squared plus 0x minus 4, right? I've added 0x here. Does this change anything at all? Well, no, right? Because 0 times x is just 0, and we can always add 0 to anything. Adding 0 doesn't change the total value, right? It doesn't change anything. It doesn't impact the -4, doesn't impact the x squared. And the reason that I put the x here is for a very special reason, because now it looks a lot like ax squared plus bx plus c. We see now that we have this middle term here, the bx, by adding that 0x in the middle, right? Okay, so with doing that, now we can look at factors of -4. And what are my factors of -4? Well, we have, if we're talking about -4, we have plus or minus 1. And remember, because it's a -4, the other factor in the pair has to be flipped, right? So if I have a positive 1, the other factor has to be a -4. And then same thing, if I have a -1, the other factor has to be the +4, which is why we have a plus minus here and a minus plus for the 4, okay? It's really just to reinforce the fact that the signs are going to be opposite because we have the negative right there. Okay, so that's one of our factor pairs. And what is the other factor pair? Well, plus minus 2 and then minus plus 2. And you think to yourself, okay, well, which one of these factor pairs is going to give us the 0 when added together? And you realize, oh, it's going to be this one. And it doesn't matter which one you pick first. If you pick the -2 first, then you're just going to have the +2 for your second. And if you have the +2, then your -2 is going to be second, right? So you realize, oh, well, this is really just the same thing as x plus 2, x minus 2, and oh, wait, difference of squares. Okay, so if you really get stuck and you don't remember the difference of squares, I recommend adding this 0x in between, because then you can still go back to the second method that we discussed, which is looking at factors of c and then seeing what factors of c add up to give you b. Okay, so I hope that made sense. You don't really have to remember that as long as you remember difference of squares, because it is just substantially easier. Okay. So what I want to do is I want to do one more example for the special cases, and then we'll move on to another method. So let's look at factor 2x cubed plus 54. And you think to yourself, oh God, we have to factor 54 somehow. This looks horrible. What are we going to do? Well, the first step that you should always take is look for things that are in common. Look for a number that you can pull out, or a couple numbers that you can pull out that are going to make your life easier. So we see here, oh, well, 54 is an even number, and we have a 2 here multiplied against the x cubed. So why don't I just pull the 2 out? So I'll pull 2 out, and we now have x cubed plus, and what is a number multiplied by 2? That'll give us 54. Another way to think about it is what is 54 divided by 2? And we end up with 27. Okay, so 54 divided by 2 gives us 27. And we say to ourselves, okay, well, this looks a lot better. Now we don't have to work with the 54. We just have to work with the 27. There's no coefficient in front of the x cubed. What do we do here? And again, what I really want to hammer into your heads is when you see x cubed and when you see a plus here, think, oh, this might be a sum of cubes. And you think, is 27 a cube? And if you don't know off the top of your head, go through the list. Well, what is 1 cubed? 1 cubed is 1 times 1 times 1, which is still just 1. What is 2 cubed? 2 cubed is 2 times 2 times 2, which is 8. And then you think to yourself, oh, what about 3 cubed? Well, 3 cubed is 3 times 3, which is 9, times 3, which is 27. Easy, right? So now we have a scenario where we have 2 on the outside, and we have x cubed plus 3 cubed. And what we see here is a sum of cubes, right? We have a cube plus a cube, sum of cubes. And I want to mention something that I don't think I mentioned in the last lecture, and it will make your life a little bit easier when trying to remember how to factor sum of cubes and also how to factor difference of cubes. And it is with the acronym SOAP. So SOAP. AP, SOAP. Okay, what does SOAP stand for? SOAP stands for same sign. So this is what SOAP is referencing is the signs of what we're factoring into. So same sign, followed by the opposite sign, and then always positive. So what do I mean by this? Well, you guys may or may not recall from the last lecture, a cubed plus b cubed. This is the sum of cubes, right? What this is really going to come out to be is a binomial times a trinomial, right? We have a, we have b, and then we have times a squared, ab, and b squared. And you're thinking to yourself, God, what are the signs? What am I going to do here? I do not remember, right? So now SOAP should help you. First, the first sign that's going to be present in the binomial is the same sign. So we have a sum of cubes. The sign that we're talking about in question here is positive, right? It's a plus. So same sign, a plus b. The next one is always going to be opposite of whatever the first sign was. So a squared minus ab. And then the last one is always positive. So b squared. And before I go and finish off the problem that we were doing before, imagine we had the difference of cubes, so a cubed minus b cubed. We are still going to apply SOAP, right? So now a minus b, right? Again, same sign. We're keeping the sign the same. Okay, so a minus b times a squared plus ab, right? SOAP, first we have same, then we have opposite. So plus ab. And then always positive, right? Okay, so hopefully SOAP should help you guys when doing difference of cubes or sum of cubes, because I don't think that I referenced that acronym the last time that we did this. Okay, so we'll go ahead and finish this off here. So with SOAP in mind, we are going to factor x cubed plus 3 cubed. And keep in mind, we are going to keep this 2 all the way on the outside of everything. Okay, so 2 is going to remain on the outside. So to factor x cubed plus 3 cubed, we know that we have to follow the sum of cubes formula, which means we're going to get x plus 3, right? SOAP. So first we have the same sign. Sorry, that might look like a plus or minus. I don't want to give you guys that impression. So first we have the same sign, right? And then we have x. Got carried away. I was writing in the red pen. X squared minus, right? So opposite. And then it's AB, right? So in this case, 3x plus, because it's always positive, 3 squared, which is 9. And that's it. That's how you factor the sum of cubes. If this didn't make sense to you at any point, please reach out to me. This may or may not be important on your homework, but it will definitely be important going into your midterm. I just want to make sure that everybody understands how to factor the sum of cubes and then also the difference of cubes. It'll be the same idea. You're just using SOAP to figure it out. Okay, so this is going to be our final answer here. And how do we know that it's our final answer? Well, we have 2 times whatever is in this parentheses times whatever is in the other parentheses, right? And I'll put another dot there. Notice that outside of the parentheses, there are no other things happening. There's no addition, there's no subtraction, right? So that's how we know that we're fully factored. Okay, so now that we've done that, we have another method, and this is going to help us. This method here is going to help us when we have a coefficient in front of x squared. So you guys might remember in the previous example we did, we had x squared plus 7x plus 6, right? And the reason that we were able to do this relatively easily is because the coefficient in front of x squared was a 1. Well, now we're going to look at what happens when a, or the coefficient of x squared, is not equal to 1. So let's look at an example. Let's say we had 6x squared plus 17x plus 7. And now you look at it and you say, okay, first step, right? First step always is you want to look and see if you can pull anything out of all the terms. And you say, okay, well, again, I might be able to pull the x out of the first 2 terms, but that's really not going to help me solve this. It's not going to help me fully factor this. So that's out. You look at the numbers 6, 17, and 7, and you say, okay, well, 2 of these are prime, so there's no way that we're going to pull anything out of these, right? Like, we can't pull a 3 out because even though we could pull a 3 out of 6, we can't pull a 3 out of 17 or 7. So that's out. So already you're saying, okay, well, we can't do anything for that. So what we have to do is before we examine the factors of 7, we actually have to multiply this coefficient times the last number. So we're going to do it off to the side. We're going to say, okay, 6 times 7. And 6 times 7 is equal to 42. Okay? And you might be wondering, well, why didn't we have to do that before with the example of x squared plus 7x plus 6? And I'll tell you, you actually did. It's just that the coefficient here is 1, so it's basically like you skipped a secret step. What you really technically did was 1 times 6 is equal to 6, and then you examined factors of 6, right? Well, we're going to do the same thing, except instead of the 1, we're looking at a coefficient of x squared being 6. So we're still doing this secret step that you didn't have to do before. So 6 times 7 gives us 42. And now what we're going to do is we're going to examine the factors of 42. And you might think, oh, God, you know, this might be terrible. But just write it out. Just go slow, right? So we know, obviously, we're going to have plus or minus 1. And because it is a positive 6 times a positive 7 here, we know that we're looking at positive 42, right? So that means that the signs of the factors, like the factor pairs, the signs of them are going to match. So plus or minus 1, plus or minus 42. And what I mean by them matching is just that, okay, well, we have the plus 1 and we have plus 42, or we have negative 1 times negative 42, right? Okay, then you say to yourself, okay, well, 42 is even, so 2 has to be a factor, right? So we have 2 plus or minus, and 2 times what gives us 42? Well, that's pretty easy. It's 21, right? And again, plus or minus. And now the last step here is you do have to check 3, right? So what about 3? And you think to yourself, is there a number times 3 that gives us 42? And you say, well, yes, actually there is, and it's 14. And if you don't remember this, if you can't, like if it's really hard for you to come up with factors, there's really no way that I can check that you're using or not using a calculator. So just start dividing. If you really don't know what all the factors are of 42, just start dividing 42 by 1 and you get 42. Then divide 42 by 2, you get 21. And just, you know, keep going in that sense. And then 42 divided by 3 gives you 14, right? So now we have some factor pairs here, and we say to ourselves the exact same thing that we did with this example, the x squared plus 7x plus 6. And in this example, we ended up with 1 and 6, positive 1 and positive 6, because positive 1 and positive 6 equaled 7, right, when we added them together. And that's, again, what we're looking at. We're looking at this middle term here, the 17. So now we have to ask ourselves, well, what numbers, when added together, are going to give us 17? And you say, oh, hey, look, we have the plus 3 and we have the plus 14. So if we get rid of the negatives, right, all the negatives, and then these guys are definitely out, we're left with 3 plus 14, and that's 17. Great. So the only other step that's going to be different than the one above is we're just going to write those out. We're going to write out, okay, 6x squared plus 3x plus 14x plus 7. And the reason that we're doing this, and the reason that we can do this, is because you look and you say, okay, well, 17x is really the same thing as 3x plus 14x, right? We're just splitting it up by the factors that we determined before. So these guys, when added together, would give us the 17x. I just split it up by the factors that we had. Okay, and now you might be wondering, okay, well, we split the 17x up, but what are we going to do? And what we're going to do is a process called grouping. So we're going to group the terms in pairs of 2. So what I'm going to do is I'm going to draw parentheses around 2 of the terms. And you can technically mix them up. We don't have to do it with these 2 pairs. And I'll show that in just a second. But just for the sake of finishing this problem, this is how I'm going to do it. So we have 6x squared plus 3x. And now let's examine one at a time. So we're going to look at this guy first. 6x squared plus 3x. And now it goes back to the very first method that we talked about, which is pulling out as much as we can from both terms, right? So what can we pull out of 3x and 6x squared? Well, we can pull out a 3x. And when we pull out a 3x from 6x squared, we're just left with a 2x. And we pull out a 3x from 3x, all we're left with is plus 1, right? Because 3x times 1 would give us 3x back. Okay, so that one's done. Now we have to look over here. What can we pull out of 14x and 7? Well, we definitely can't pull out an x, right? So we're only going to be pulling out a number here. And what number are we going to pull out? Well, we can take 7 directly out. So we take 7 out. And when we take 7 out, we are left with 2x plus 1, right? When you take 7 out of 7, we're left with 1. And you might realize here, oh, wait, these are matching. 2x plus 1 and 2x plus 1. Well, is that by coincidence? No, it's actually going to be one of our factors. What we're going to do here is we're going to recall the distributive property, right? But we're going to kind of recall it in the opposite direction. If you guys remember, we had A times B plus C gave us AB plus AC, right? Well, let's think about it going the other direction. What if we started with AB plus AC? And we see here we have something times something plus something times something, right? Well, what is my A in this case? A is going to be this whole expression 2x plus 1. So what am I going to do if I'm going in reverse? Well, I'm going to pull 2x plus 1 out of both of the terms, right? So if I pull 2x plus 1 out, 2x plus 1. If I pull 2x plus 1 out of the first one, we're left with 3x, right? So 3x, because 2x plus 1 divided by 2x plus 1 is just 1. And then if we pull 2x plus 1 out of the second guy here, all we're left with is a plus 7. And this here is your final answer. That's it. Okay, and now again, we can go back and double check our work. And how is this going to work? Are we really done? Well, sure. Let's go ahead and FOIL, right? 2x times 3x. Well, 2x times 3x is 6, and I will write this in green just again to reinforce that this is a check. 6x squared. Then we do outside, so 2x plus 7, and we get 14x. Then we do the inside, which is plus 3x. And finally, we do the outside, which is plus 7. And then when we condense this all, 6x squared plus 17x plus 7, which is exactly what we started with way up here. Okay, so there's a little bit more to it when our leading coefficient to the x squared is not equal to 1. And for the record, you still need to do this exact process if your leading coefficient is even -1. Okay, so if, for example, it were -1, and it's not going to work out with all the math that we did before, so I'm not going to try to go through it, but if it were -1, then what you would do is instead of the positive 6 times 7, you would do -1 times 7, and then you would end up getting -7 here, and you would look at all the factor pairs of -7, okay, or whatever your number were. So whenever this number here is not 1, you have to do it this way. Okay, and just as a short recap, again, the idea here is we first start by multiplying a times c, so multiplying these two numbers, the leading coefficient and the constant. We then examine the pairs, the factor pairs of what we got for our multiplication answer, and we pick the pair that will add up to be our middle term here. So we picked 3 and 14 because it added up to be 17, and we split it up as such, 3 and 14, right? And then we did the process called grouping, which is where we put parentheses around everything, and then we pulled out as much as we could from each parentheses. Now, earlier I said, okay, well, did I have to group this way? And the answer is actually no, we didn't. So I'm just going to go ahead and erase this. And I'm going to be writing in blue just to show you guys that it's going to slightly be different, but not really. So before we had 6x squared. And now I'm going to change the order of it. I'm going to say 6x squared plus 14x plus 3x plus 7. And you're like, okay, well, how is this going to work out? Well, again, you're going to do the same thing, right? You're going to start by drawing parentheses because parentheses don't change the value, right? Parentheses don't do anything when we just, draw them around each other. And now we say, okay, well, what's the biggest number that we can pull out of 6x squared and 14x? And you say to yourself, well, it's looking like it's probably just going to be 2x, right? Because 2 goes into 6, 2 goes into 14, and we can also pull an x out of both. So let's start there. We pull 2x out of the first expression. And when we do that, we're left with 3x plus 7. And then you notice, oh, wait, we also just had a 3x plus 7 over here. And what is my leading coefficient when there's nothing in front of it? Well, my leading coefficient is actually just 1. And now we're going to do that distributive property, but just in reverse, right? Going in the other direction. And again, the same thing is we're just going to pull out the 3x plus 7. The only difference between over here, what we did in the first time, and what we're doing here on the second time is that our a here and here are just going to be reversed. So instead of our a being 2x plus 1, our a is 3x plus 7. So we take 3x plus 7 out of both pieces, and all we're left with is 2x plus 1, and we see here that is exactly what we had before. 2x plus 1 times 3x plus 7, and it doesn't matter the order, right? 3x plus 7 times 2x plus 1. So don't be afraid that you're going to mess up because you write your factor pairs in a different order. It just means that you might, have to go about it a slightly different way, but you'll get to the same answer nonetheless. Okay? So I want to give you guys another example. Go ahead and try your hand at the next classwork assignment. Now, the next classwork assignment, you actually didn't need to do any of the beginning part. So you didn't need to do, the a times c to figure out the factor pairs. You didn't need to split the factor pairs up. All I really want you to do is focus on the grouping part. Can you do the grouping part? Okay, so go ahead and pause the video here, try your hand at it and see what you come up with. Okay, so hopefully that went pretty well for you guys. Let me write the classwork assignment down. So it's x cubed plus 3x squared plus x plus 3, right? And you say to yourself, okay, well, first step that I'm going to do to grouping is we draw the parentheses, right? We draw the parentheses around two of the terms in pairs. Okay. So we look at our first pair here, x cubed plus 3x squared, and we say, what is the largest thing that we can take out of both? What is the greatest common factor we can take out of both? Well, we can't take out any coefficient, right? Because the coefficient here is just 1. So we can't take out anything in terms of 3. But we can take out x squared, right? So if I pull out an x squared here, I'm left with x plus 3. And then you say to yourself, oh, well, again, I already had x plus 3 here, right? And what's my leading coefficient? It's x squared. Well, I'm sorry, it's the plus 1, right? So now what I'm going to do is I'm going to pull x plus 3 out from both terms, x plus 3, and all I'm left with is x squared plus 1. And that's it. This is your final answer. You have x plus 3 times x squared plus 1. Now, you might be thinking to yourself, well, wait, we still have an x squared here. Can we factor this anymore? Can we factor this expression here, underlined in red, anymore? And the answer is actually no. So again, you might be thinking, well, what about difference of squares? We have a square here, right? We have the x squared, and technically 1 is a square, right? 1 is the same thing as 1 squared. The thing that you're missing is the difference. This is not a subtraction, this is an addition. And when we get to later chapters, we're actually going to see something that that's going to apply directly to this. But all you have to know for right now is this is irreducible. There's nothing else that you can do with it, at least with real numbers. And again, in a future chapter, we're going to slightly discuss a concept called imaginary numbers or complex numbers. But for the sake of this class, you really do not have to worry about it, and you can just say, this is irreducible. This is my final answer, x plus 3 times x squared plus 1. Okay? All right, good. So there is that. Ugh. And why don't I give you guys one last class work assignment just so you also understand the earlier part of the a times c. So try your hand at the third classwork assignment for this chapter, which is 24x squared minus 6xy minus 9y squared. Now this one might be a little bit tricky. The only hint that I'm going to give to you guys before you actually start it is remember all of the different methods that we had, right? And remember the most important one, the first one that I'm telling you guys to start with, is always to look for something that you can pull out of all the terms. Okay, so try your hand at it, see what you guys come up with. Okay, so going through this, again, the first step that I told you is you should always be on the lookout for something that's going to simplify the expression, something that you can pull out of all the terms to make your life easier. Now, in regards to the variables, there's not a single variable that we can actually take out of all three terms, right? There's an x here, there's an x here, but there's no x in the final term. There's a y here, and there's a y here, but there's no y in the first term. So we can't pull out variables. So you say to yourself, okay, well, what's next? What can we do? And then you say, okay, well, what about just numbers? And you say to yourself, oh, 3 goes into all of these, right? So I'm going to pull 3 out of everything. And when I pull 3 out of everything, we have 3 times 8x squared minus 2xy minus 3y squared. Okay, well, that already made things a lot better because now we're not dealing with a 24. Okay, so what was our step when this number here is not equal to 1? Our step is we have to multiply that number times this number here, right? So 8x squared, and we are only concerning ourselves with the 8 here because it was a positive 8, right? So 8 times, and remember, we're talking about the sign of that last number as well, right? So -3. And we end up with a -24. And now we say, okay, what are factor pairs of -24? So we go down the list. We have plus or minus 1, minus plus 24, right? Again, the signs have to be flip-flopped because we have a negative there. So plus minus 1, minus plus 24. Then we have plus minus 2, minus plus 12. We just keep going down the list. Plus minus 3, minus plus, 8. And last but not least, plus minus 4, minus plus 6. So these are all the factor pairs for -24. And we look and we see, okay, well, we need the factor pair that when added together is going to give us a -2. That's what we care about, a -2. And we say, okay, well, obviously, doesn't matter if they're plus or minus, that's out. It's going to be way too big, right? If we add 1 and 24, whether it's a -23 or a positive 23, it's still going to be out. Okay, same thing for this guy, and even same thing for this guy, right? We can add all the different combinations. We're never going to get a -2. But when we look at the final one, we say, okay, well, what if we try a -4 and a positive 6? Well, that's going to be out because we're going to end up with a positive 2. But if we have the +4 and the -6, well, that's definitely going to work, right? And just to show, 4 plus a -6 is the same thing as 4 minus 6, which is -2. And that is exactly what we want, right? We wanted -2. So what we're going to do here is we're going to go back and we're going to say, okay, well, we still have the 3 on the outside of everything, right? And we still haven't changed the 8x squared. We still haven't changed the -3y squared. But what we can change is we can put in the plus 4xy and the minus 6xy. And you might be asking, why is it xy? Well, it's because even though we're adding things together, we still need to keep the variables the same from the middle term, right? So we still haven't changed these variables in between. It's still xy, so that's going to drop down, okay? So great, we've split it up, and now if you go backwards and you say, well, is this working? Is this actually, what I need? And you add these guys, right, the 4xy and the -6xy, you will still get the -2xy. So you know that you're on the right track. Okay, now what was the second to last step? The second to last step is we're going to go ahead and group, right? So what we're going to do is we're going to group the 8x squared plus 4xy. And then we're also going to group the, and I'll put a plus sign here just because it might be a little more intuitive for you guys to not pull the negative out immediately. We'll put the plus sign there, and we're going to have grouping the -6xy and the 3y squared, right? Okay, so now we're just playing the game of what can we pull out? What is our greatest common factor? Well, 3, again, stays all the way on the outside. What can I pull out of 8x squared and 4xy? Well, there's a y only present in one of them, so we can't pull out a y, but we can definitely pull out the 4, and we can definitely pull out 1x, right? So 4x. And we see, okay, well, 4x, what's left? 2x plus, and what's left here? Just the y. Okay. And we're going to do the same thing here. And I'm not going to put the plus sign immediately because what we're going to see is we're actually going to try to pull out a negative sign. So when we pull out a negative sign, which we're going to do here, because both of these terms are negative, right? So we can do that. Now what else are we going to pull out? Well, we can take a 3 out for sure. So we take a 3 out. And we can also take one y out because there's a y present in both of these. So we take a 3y out. And what is left? Well, all we have left is 2x and then plus y. And again, the reason that these terms are positive, these terms that I've underlined here, is because we took the negative out from both of them. Okay, and all there's left to do is, hey, these match. This is your clue that you're almost done when you have these matching expressions. So what we're going to do is we're going to say 3 times, and then we're going to pull out the 2x plus y, and all we have left is the 4x minus 3y, and you're done. Okay, I know that was a lot of steps, and we're going to shrink this so that we can kind of go over it just as a quick recap. So we started with the 24x squared minus 6xy minus 9y squared. The first thing that we did was we looked to see the greatest common factor that we could take out, and in this case, it was just a 3. That was all we could take out, right? So we took the 3 out. Then what we did was we followed the procedure of multiplying a times c, the coefficients, right? And these coefficients were 8 times -3, which led us to -24. We looked at the factor pairs of -24 and found the ones that would add together to give us a -2. And then we just ported them in, right? We just plugged them directly in with the +4, the -6. And last but not least, we did the grouping phase where we put them in pairs of 2 and pulled out, again, the greatest common factor that we could pull out from both of them. And by reversing the distributive property, we pulled out the 2x plus y from both and ended up here. Okay? So I know it's a lot of steps, but intuitively, once you do it enough, it should start making sense. And that's what I'm kind of hoping for you guys. So again, I know that I am starting to run over here. This is probably where I would normally stop our class, but I do want to get to the rational expressions part, so just bear with me, just so I can make it all in one lecture video and I don't have to do 2 separate videos where one is only like 15 or 10 minutes. Okay, so a rational expression. Again, what is the definition of a rational expression? A rational expression is just a quotient or division of 2 polynomials. Okay, so the best way to just get into it is just with an example. So I say I want you to simplify. Sorry, I realize that I'm still zoomed out, so there we go. So I want you to simplify, and here's the following expression. X squared plus 6x all over x squared minus 36. And I'm going to write this over here where x does not equal plus or minus 6. You don't necessarily have to concern yourself with this just yet. This really is in regards to domain, and we will talk about domain at length for the rest of the semester, but we haven't covered that yet. I'm just putting this here just as a safety net, so if you ever go back to these lectures, once we do cover domain, you see, oh, this makes sense. And the reason that it should kind of make sense is what happens if you put positive or -6 into x right now. Well, specifically in the denominator, you would get either, it doesn't matter if you plug in x or -x, you get, 6 or -6, you would still get 36 in the denominator. So 36 minus 36 is 0, and you end up with a 0 in the denominator. And what do we know about 0 in the denominator? Doesn't matter if it's a polynomial, doesn't matter if it's a real number. 0 in the denominator makes the fraction blow up, right? It's not defined. So I'm saying here where x is not equal to plus or minus 6, and that's part of the domain that we'll talk about later. Okay, but right now we're just talking about simplify the x squared plus 6x over x squared minus 36. And you say to yourself, okay, how are we going to do this? Well, you break it up into the numerator and then you break it up into the denominator. So first we're going to factor the numerator. And when we're talking about just the numerator, we're just talking about x squared plus 6x, and there's not much going on there. What can we pull out? Well, we can take an x out, right? If we take an x out, we're just left with x plus 6. And that's it, x plus 6 in the numerator. Okay, so x times x plus 6. And in the denominator, we have a square, we have a difference, And we have another square, right? 36. And if you're not sure that this is a square, right, if you just meet the first two criteria, check the number. See if there's a square in there, right? Start at 4, right? 4 times 4 is 16. 5 times 5 is 25. And then you think, oh, yeah, duh, 6 times 6 is 36. So we have a difference of squares. And what do we know about a difference of squares? Well, it's just going to be a plus b times a minus b. And in this case, that's going to be x plus 6 times x minus 6, right? And what we're going to do here is we're going to follow the same exact ideology of if you had a real number, right? So say just before I finish this, I had 2 times 3 over 3 times 7, right? What can we do here? Well, we see that we do have, since everything's being multiplied against each other, they're all factors, right? We can just cancel the 3 over 3, right? Because it's just simplifying the fraction, and all we're left with is the 2 over 7, right? We're going to do the same thing here. We're going to look for things that are similar in both the numerator and the denominator. We're going to look for terms that are identical, and then we're going to cancel them out. So what term is identical here? And we see it's the x plus 6, right? X plus 6 over x plus 6 just simplifies to give us 1, and all we are left with is x over x minus 6, and that is our solution. Okay, so again, should make a lot of sense if you understand the factoring part. That's why I wanted to include this in here. Now, again, just like regular fractions, we can also directly add the numerators of polynomials, or I'm sorry, of rational expressions, if the denominators are the same. So let's, again, just recall, if we have 3 over 7 plus 2 over 7, as long as the denominators match, we can just add the numerators, right? So that's the same thing as 5/7, right? And the same thing is going to hold true. I'm just going to quickly run through this. X plus 6 over x squared plus 1 plus 8x over x squared plus 1. Well, this is going to be the same thing as we add the numerators. So we add 8x and x, and we get 9x, and nothing happened to the 6, right? And we just get 9x plus 6 all over x squared plus 1. And yeah, technically, if you really wanted to, you can pull out the 3 here, right? You can say, well, this is really technically just 3 times 3x plus 2 all over x squared plus 1. But I wouldn't take any points off if you just left it at the 9x plus 6, because there's no more simplification that you can do. Okay, so let me go ahead and do one more example with you guys when the denominators isn't, when they don't match, and then I'll let you guys try the last classwork assignment on your own, okay? So I want to subtract the following: 5x over x plus 2, and again, we're subtracting 8 over x minus 2. And we say to ourselves, okay, well, the denominators clearly don't match, so we can't do the subtraction part yet. And what do we do with regular numbers as part of a fraction if the denominators don't match? Well, we look for a common denominator, right? And that's the exact process that we're going to do here. So since we have an x plus 2 here in the first expression, that means that we have to multiply this guy over here by x plus 2. Ooh, came out horrible. I'm sorry. X plus 2 over x plus 2. And then the same thing over here, right? We have an x minus 2 in the bottom of the right expression. So we have to do x minus 2 over x minus 2. And this should make sense, right? Because again, when we're dealing with regular fractions, we have to multiply both the top and the bottom by whatever we're doing, right? Because that way it doesn't change the value, right? X minus 2 over x minus 2. If we simplify this, that's just 1. We're basically just multiplying by 1, even though it's a polynomial. And it shouldn't change the value. It's only going to change the appearance, okay? So we multiply and we get, okay, well, 5x times x minus 2. Essentially what you're going to do is you're going to distribute the 5x to both pieces. So what's 5x times x? We say that is 5x squared. 5x times negative 2 is negative 10x, right? And then we have x plus 2, that's what we had to start with, times x minus 2, and that's what we essentially multiplied against it, right? And we go over here, we still have the subtraction, and let's deal with the next fraction. Again, we're going to multiply the 8 times everything in here, so we get 8 times x, and then 8 times 2, which is 16, and once again, we have x plus 2 x minus 2. And we're almost done, right? Because now we have common denominator, which means now we can just do the final subtraction. So we end up with 5x squared minus 10x, and the negative applies to both pieces here. Don't forget to apply the negative to everything in the numerator, okay? So that's the negative 10x minus 8x minus 16, right? The negative applies to the positive 16. And this, well, you guys should remember this. What's x plus 2 times x minus 2? When you have a plus b times a minus b, that's the difference of squares, right? So we end up with x squared minus 4 all on the bottom. Okay, and all we're going to do here is simplify this down. So we have 5x squared. No, there's no other x squared term, right? So nothing's happening to that. 5x squared. There is the negative 10x minus 8x, so that's going to be minus 18x. And then minus 16 all over x squared minus 4, and that is your final answer. So just looking at this, just to recap, all we're doing is first we find a common denominator, which in this case was x plus 2 times x minus 2, right? We just basically multiplied the denominators against each other, and whatever we do to denominators, we also have to do to the numerator, right? So we distribute the numerator times the x minus 2, and then once we have the common denominators, we can finally do the subtraction, and don't forget to apply the negative sign to both pieces in the numerator from whatever what is actually being subtracted. Okay, and the x plus 2 times x minus 2, not to belabor the point, but x squared minus 4 because of difference of squares, or you could just FOIL it. But once you get good at it enough, you'll start recognizing that pattern, a plus b times a minus b. And it just leaves us to this answer. So I know this video has been going on for quite a bit, and I feel bad. Let's just cap this off with our last classwork assignment. So the last classwork assignment is a mix of everything that we've kind of talked about so far. We talked about complex fractions in the past and how to handle fractions, and now we're going to include polynomials in this, okay? So we have 1/2 plus 1 over x all over x squared minus 4 over 2x. And again, I'm just going to write a comma here where x is not going to be equal to 0 or plus or minus 2 for the same reason that we couldn't have the plus or minus 6 from before, right? Because if we look at the very bottom here, the 2x, if x were equal to 0, well, that would be 2 times 0, and that's, 0 in denominator, and the world blows up, right? So we can't have that. And then similarly for the plus or minus 2, and you guys can figure that one out. Okay, so we are mainly just concerned with simplifying this main complex fraction. Go ahead, give yourself a couple minutes if you need, maybe even 5 minutes. Try to really work this out and see what you come up with. Unpause the video when you are ready. Okay, so the way that we're going to approach this is the way that we approach any complex fractions, which is we're going to try to make our lives easier. So in the numerator, we see that we have two different fractions being added against each other, right? We have a 1/2 plus a 1 over x, and I don't want that. I want it to be one fraction, so that way eventually we can do the KCF, right? We can do the keep, change, flip. So what I'm going to do is I'm going to figure out what my common denominator is between 1/2 and 1 over x. Well, to get the common denominator is just going to be 2x, right? So that means for this guy, I have to multiply by 2 over 2. And for this one over here, I have to multiply by x over x. And we see again, x over x is 1, 2 over 2 is 1. We're not changing the value, we're just changing the appearance. So by doing so, we have x over 2x plus 2 over 2x. And this is still all over x squared minus 4 all over 2x. Okay, now what we're going to do is, now that we have the common denominator in the two fractions in the top, we're just going to combine those. And just for the sake of room, I'm just going to keep writing off to the right here. So now we have 2 plus, sorry, that's a plus, 2 plus x all over 2x. And this is all over x squared minus 4 over 2x. And now at this point, if you get good with complex fractions and you realize, oh, hey, look, I have a 2x here and a 2x here, it's really just 2 plus x over x squared minus 4. That's totally okay, and you can just do it that way. But I want to really reinforce the keep, change, flip here. So this is the same thing as 2 plus x over 2x divided by x squared minus 4 all over 2x, right? And keep, change, flip. What does that mean? That means we're going to keep the first fraction the same, so 2 plus x all over 2x. We're going to change the divisor to a multiplication, and we're going to flip the other one, so 2x over x squared minus 4. And we see here, oh, 2x and 2x are going to cancel out, right? We have 2x in the denominator, 2x in the numerator. They're gone. So we are left with 2 plus x over x squared minus 4. And you ask yourself, are we done? And the answer is actually no, because what do we have here with x squared minus 4? We have a square, we have a square, and we have a difference of squares, right? So we can keep going, and we say, okay, well, 2 plus x, and we have x plus 2, x minus 2, right? Difference of squares is a plus b times a minus b. I really want you guys to remember that. And you say to yourself, oh, wait, we have an x plus 2 here and a 2 plus x here, but 2 plus x is really the same thing as x plus 2. We can just change the order because it's addition, which means that they're really the same term, so these cancel out, and all we are finally left with after everything is said and done is 1 over x minus 2. And that's it. This is your final solution. Okay, guys, I know that was a long video, and I know that there was a lot of information packed in it, so really try to dissect it. You might have to watch this one twice, but you know, you do have Labor Day weekend, so you can watch it going into Friday and then re-watch it if you need to when you do the second homework, and then hopefully it makes sense if if it didn't on the first time. Of course, you can always email me, and I'm more than happy to answer any questions, whether it's regarding the lecture, classwork, or homework. In any event, I hope you guys have a great day or a great night whenever you're watching this. I will see you all on Friday, and if you were not present, then I will see you guys on the Wednesday after Labor Day. Okay? All right, guys, have a great one. See you later.